We're kicking things off by preparing our light source. Using needle nose pliers, we carefully bend the leads of these high brightness blue LEDs. We're soldering them together into a tiered, triangular architecture. This cascading grid isn't just for looks. It allows us to group the LEDs into columns for a dynamic sequential effect. To keep our wiring organized, we're using a multicolored rainbow ribbon cable. We strip the ends and solder each distinct color to the common cathode leads of our LED columns. This color coding is crucial. It makes it much easier to track which wire corresponds to which sequence step once we connect them to the control board. Now for the brains of the operation, the CD4017 decade counter. This IC is what creates the chase by shifting the high output from one pin to the next. We're using an IC socket to prevent heat damage during soldering. Here we bridge pins 8 and 15, which effectively connects the ground to the reset pin, allowing the counter to cycle continuously. To drive that counter, we need a steady pulse, which comes from the classic NE555 timer. We're configuring it in astable mode by bridging pins 4 and 8 and adding a 10 microfarad electrolytic capacitor along with a 1000 ohm resistor. We're building the timing foundation. A 50k ohm preset potentiometer is added here, so we can manually tune the speed of the pulses later. We're finishing the timer circuit by adding a 100 nanofarad ceramic capacitor for stability and noise reduction. Once the components are secure, we carefully bridge the output of the 555 timer to the clock input of the 4017 counter. Finally, we attach our main 12-volt power and ground lines, ensuring the entire control module is ready for action. This is where the magic happens. We bring back our LED grid and begin the meticulous process of soldering the rainbow wires to the output pins of the CD4017. By following a specific numerical sequence, mapping pins like 3, 2, 4, and 7 to our columns, we define exactly how the light will travel across the triangular display. With everything joined up, we connect our 12-volt lithium-ion battery pack. Immediately, the LEDs spring to life in a smooth, rhythmic chase. By turning the preset potentiometer with a screwdriver, we can transition from a slow, pulsing glow to a rapid-fire flicker. It's a perfect blend of simple electronics and striking visual design.